Today we're going to be using our formula sheet to go over the area of two-dimensional figures. So please don't write on it because you'll be able to use the formula sheet for any of your tests or quizzes in this class. So let's go ahead and look at the area formula for a triangle. Area equals 1/2 base times height. And I put a note up here that base and height are perpendicular, so we're looking for 90-degree angles. So you have your base and your height here on your 90-degree angles. But not every triangle is a right triangle. So taking a look at the other two, the obtuse triangle, you still have a base that's down here, but we're going to drop the altitude. That's also another name for height, okay, is the altitude. And you'll hear me say drop the altitude for the obtuse one. Now I'm putting dotted lines here because that dotted line that I just did here is not included in the base. The base is only this part of the triangle, but your height will be the height out here, that altitude. Likewise, for an isosceles or an equilateral triangle, you're going to have to drop the altitude and create your 90-degree angle, the perpendicular. So what I just did was drop the altitude, and that is the height of that triangle. So here's my 90-degree angles, but I also want to take note that when you drop the altitude in a triangle like this, it is dividing your base into two equal parts. Because sometimes you're going to have to use the Pythagorean theorem, c squared equals a squared plus b squared, if you're not given the height. And we'll go over a problem like that. So make sure you're always finding your perpendicular. The next two are the area formulas for a rectangle and square. Length times width. Length, width is just multiplying. For sides squared, remember, in a square, all the sides are equal, so you just square your sides. Last one in section 10.1 is the parallelogram. You also, since you have base and height, you need perpendicular. So to do that, you're going to drop your altitude, or your height here, to create a 90-degree angle. So that will be your height of your parallelogram, and then the base has to be attached to it. Okay, so we're going to use this side and this side, those pairs of parallel lines. But remember, you have to find your 90, so that's why we're using those two sides. So it's base times height. So go ahead and see if you can do these three. I'll show you guys what numbers to plug in and then go over the answers. For the triangles, okay, or for the first one is a triangle, you have to add up 45 and 21 to give you the base of 66 times the height 28. So you should have gotten your answer to be 924. For the parallelogram, you're using 17 and 7 for the base and height, and that gives you the area of 119. The last one, they give you the area to start is 133, and you're trying to find this will be the length of the base. So when you solve that equation, you should get your base to be 7. All right, let's try a word problem. This says that we have a carpet cleaner that cleans 2 square meters in 8 minutes. How long does it take for it to clean? Well, we're talking about area, but in this figure, we have two different shapes because we don't have a formula just for this one type of shape. So what I'm going to do is divide it up into two shapes that I see here. There's another way you can do it, but I'm going to stick with this one because right now we have a square here and a rectangle here. So area of our square is side squared. Well, our sides are side length 5. So 5 squared, the area of our square is 25. The area of the rectangle, okay, now we already have 5 here, so that means 4 is this width of the rectangle because we already have 5 from the square. So our area for this is 9 times 4, or 36, length times width. So now our total area, okay, equals 25 plus 36, which is 61. Now that is not your final answer because it's asking about how long does it take for it to clean the area of this room, which is 61 square meters. So we're going to set up a proportion because we know it's 2 square meters per 8 minutes. Well, we have 61 meters, so let's figure out how many minutes that is. So when you cross multiply, you should get your answer to be this takes 244 minutes. Okay, so make sure you answer the whole question. Now we're going to find the area of the entire shaded region. There's 3 different three different shapes here, two triangles and a parallelogram. Well, if I start with this triangle here, I notice that I don't have my height here. Because this is my hypotenuse, 52, we don't use that in the formula. We use, remember, what's connected to our 90. So we have to use the Pythagorean theorem first in our right triangle to find the height. So 52 is your C, and then you have 20 squared plus x squared. So 52 squared equals 20 squared plus x squared. When you solve that, you should get your height to be 48. So I'm going to put my height here. Now, if you notice, in this shape, the height is actually the same throughout. So I'm going to put the height here as 48, and also in my parallelogram, the height is going to be 48. So now I'm going to have to do three different formulas for the area. So the triangle in red, I'm going to go ahead and do area equals 1/2, the base 20 times 48. We're going to find that. And then our parallelogram, I'm going to go ahead and highlight in the blue here. We have area equals area equals base 80 times the height 48. And then our last triangle here in green, okay, area equals 1/2. Our base of that is 40 and our height is 48. So go ahead and calculate all those, and then what you do is you add them all together to get a final answer. Once you do that, you should get the total to be 5,280. But you have to figure out all three first, then add together. All right, so let's get into some of the good ones. It says the legs of an isosceles triangle are 6 inches. So I'm going to put 6 and 6 there. It says the base angles measure 50. So these are my base angles, and we are trying to find area and perimeter. Well, this is where we're going to have to drop our altitude, okay, because we need the height, plus we also need the base. We have nothing for our area and nothing for our perimeter. So now looking what we have, what I'm going to do is trace out this triangle and redraw it down here. We have a triangle with 6, 50, and I'm just going to put an X here because that we need to find the height. Well, we're going to have to use SOHCAHTOA. So we have opposite and hypotenuse. We're going to use the sine of 50 equals x over 6. Bring 6 out in front, so 6 times the sine of 50. Make sure your calculator's in degrees. So when we calculate this, you should get the height to be, for x to be 4.6. Okay. Now, we need the length of our base down here also. Okay, because we don't have the length of our base. Remember, that gets cut in half, so I'm just going to put a y there. So when I redraw my triangle like this, we have y, 50, and 6. We're going to use adjacent and hypotenuse to find part of the base. So cosine of 50 equals adjacent y over the hypotenuse 6. 6 goes out in front. 6 times the cosine of 50 gives you about 3.9. So that means this part is 3.9 and this part is 3.9. Now we can plug everything into our perimeter and area formulas. So when you do that, you should be able to solve it. So our perimeter would be 6 plus 6 plus 7.8, because remember we have to add 3.9 and 3.9. For the area, it's going to be 1/2. The base, we have to use the whole base. Okay, we don't use 3.9, we use this whole base of 7.8 times the height, 4.6. So you should calculate your answers to be the perimeter, 19.8, and the area about 17.94, depending on where you round. Okay, so SOHCAHTOA on this one. Next one is an equilateral. So the side lengths are 12. I'm going to go ahead and write in 12. So we're able to find the perimeter easily, but we don't have the height to find our area. Okay, so that's where we drop the altitude and we cut that in half. We're going to find the height, but this is going to be 6 and 6. That's important because when we redraw our triangle, we have 12, 6, and x. So now we're not using SOHCAHTOA, but we're going to use Pythagorean theorem to find our height. So when you use the Pythagorean theorem, 12 squared equals 6 squared plus x squared. When you do that, you should get your height to be 10.4. So now we have all the information for our area and our perimeter. Okay, so plugging it into the formula, we should get the values. Perimeter, 12 plus 12 plus 12. Area 1/2, the base of 12. So remember, you have to use this whole base. Don't use the 6 in the area formula. Times the height, 10.4. So our answer, when you solve that, should be 36 and 62.8. That was all section 10.1, so let's talk about 10.2. The area of a rhombus is actually not on your formula sheet. You have to memorize this. Okay, so the formula for a rhombus is 1/2 d1 times d2. So d1 is the whole diagonal times d2, which is the other whole diagonal. Okay, so remember, these two parts are equal, and then these two parts are equal. Okay, sometimes I also write diagonal 1 times diagonal 2, all divided by 2 is the area. It's the same formula. So let's go ahead and try one. So in this rhombus, it gives us 2.7 as part of the diagonal. Well, remember, they're bisected, so that one's 2.7. Also, this one is 1.4. So we have to add those up to get the length of the diagonal. So plugging into our formula, your area should be 5.4 times 2.8. And I'm getting that from adding 1.4 and 1.4 to get 2.8. And then 2.7 plus 2.7 gives you 5.4. And then divide by 2. So you should get the answer to be about 7.6. Let's try 2 more. Okay, go ahead, pause, try to figure this out on your own. I'm going to go ahead and show you guys the formulas and what numbers to plug in. So in this one, it's the same thing. You have to add 12 and 12 and 18 and 18 to get 36 and 24 and divide by 2. So your answer for this rhombus is 432 meters. Now this one's a little bit different because it gives you the area. And so now you have x and 15. So we're just working on backwards in the formula. So this is what you would plug in to your formula. 300, which is the area, equals 30. And remember, x plus x is 2x, not x squared. So when you solve this equation, you should get x to be 10. Okay, go ahead and try and make sure you can solve that equation on your own. This one is on your formula sheet. Now, because we have base and height again, we are going to have a 90-degree angle. The bases of the trapezoid, okay, are the parallel lines. That's what you're going to use as B1 plus B2. Your height, you're going to drop the altitude, just like we did in the parallelogram, and that's going to be your height. Take note that this is a right triangle here. Also, you could drop the altitude from here and you get another right triangle. You can have a rectangle or a square with inside here. So just pay attention to what numbers they give you, and we'll do an example of that. First one, just plugging it in, area equals 1/2 height, B1 plus B2. So when you plug that in, 1/2, 6 is the height here because it's connected to your 90s, and then add your bases, 6 plus 8. So when you solve that, you should get 42. The next one's a little bit different, just like that rhombus one, where they give you the area, you're trying to find your height now. You're just going to plug everything into the formula. So when you do that, you should get 12 equals 1/2 x times 7 plus 5. You can solve this different ways. As long as you can get the answer to be 2 yards, or x equals 2, then keep doing the way that you do. Now here are the fun ones. They're a little bit different. Okay? This first one, you have the bases here. You have B1 is 10, B2 is 24, but you do not have this height, okay? You're missing your height here. But we can figure that out because once I drop that altitude, okay, the height, I have this triangle here with a 45. We're trying to find this. Well, if it's a 90 and a 45, remember that's a 45, 45, 90, so it's isosceles. So this part and that part's equal. We can actually figure out what this length is because if you notice, right now we have a rectangle here where 10 is up there, so this side's 10. Well, we're going to subtract 24 minus 10 will leave us with the part of the triangle to be 14. So if this is 14, then our height is 14. Okay, so make sure you bring that 10 down and then you subtract from your whole base of 24. So plugging it into your formula, you should have 1/2 times the height, and then the sum of the two bases, 10 plus 24. You work it out, and you should get the area to be 238. Now, the next one we have, our height is 15. We have one of the bases is 16, but we're missing the other base. Okay? Well, I'm going to go ahead and draw the height over here as 15, because what I can see now is I have a right triangle, and I can use Pythagorean theorem to find the other side of my right triangle. Once you plug that in and do your arithmetic, you get this side to be 8. Okay? Well, now I can find, remember, just like we did, here is a rectangle with side 16. Well, this down here can move to 16. So now the length of the other base is 8 plus 16, which is 24. Okay, so that one we're using Pythagorean theorem. So plugging it into the formula, area equals 1/2, the height of 15, and then base 1, 16, plus base 2, 24. You go ahead and solve it, and you should get the area to equal 300. The last shape of the day is the kite, and it is the same formula as the rhombus. You have to memorize this, so really you're only memorizing one formula, 1/2 d1 plus d or times d2. Now remember, in a kite, there's only one diagonal that's bisected. The other one is not. So that's different than the rhombus. So let's go ahead and try one. Here is the bisected one, so I know I can move 4 up there. So area equals d1 times d2 divided by 2. So plugging it into the formula, you add 4 plus 4 to give you 8 for one diagonal. And then the 10.2 plus 6.1 gives you 16.3. So doing the math in your calculations, you should get 65.2. Now, this second kite, we don't have the length of this diagonal, but I just traced out that right triangle, and we can do Pythagorean theorem, 25 squared equals 24 squared plus x squared. Once you do your calculations, you should get the side length to be 7. Okay, so sometimes you will use Pythagorean theorem for a kite. So now plugging it into the formula, 7 plus 7 is 14, 24 plus 15 is 39, 14 times 39 divided by 2 gives you the area of that kite is 273. So remember, keep your formula sheet. You can use it on any test and quiz. Please do not write down the area of the rhombus or kite, or you will not be allowed to use it.